As always, not to make things boring at the beginning, I will just take an easy problem as a warm-up. Say this one, whatever. Increase an element by 1, make it increasing. I know a solution. If you can only increase, then it's easy. If you could decrease and increase, that would be much harder. Right, let me give you a link. This is the link if anybody wants that. One second, I'm doing something on Discord now. And done. Hi, Layla. What a hard nickname to pronounce. Alright, let's see an example. Here, you can look at, for example, the middle, 2 and 4. This is alright, so if you just look at this, there is nothing you need to do. But if you look at 5, 2, you need to modify some element here. You cannot modify 5, because, I mean, modifying 5 will not help us, right? It will only make things even worse. So we need to raise 2. Actually, we need to raise 2 at least 4 times. And maybe 5 will increase some more because of other operations we make. But 2, increasing 2 up to 6 doesn't hurt. We need to do it in particular. Maybe we raise it even more. And from this logic, from this idea, the solution follows that we should move from left to right. Here, 5, 2 is the first pair, the first decreasing pair, the first one where we need to fix something, and we can greedily fix 2 to 6 because it doesn't hurt. There is no way our solution will not involve increasing 2 at least to 6. And then if you look at this increasing prefix, we could do more operations here, but it will only hurt. The answer will become worse, answer being number of operations, and we could possibly increase 6 and it will be only harder to finish the sequence. So just greedily move from left to right. Every position. What do we do? Starting from 1. If nums of I is smaller or equal, nums of I minus 1. So if we have a decreasing pair or a tie, we need to raise nums of I plus equal something. By how much we raise? By, I think, the difference. Let's see an example. If there is 8 and 10, sorry, 10 and 8, we need to raise by 3. So because 8 must be changed to 11. 3 is 10 plus 1 minus 8. It's nums of I minus 1 plus 1 minus nums of I. Increase nums of I properly and increase the number of operations made and return it. This line could be also replaced as well with this, nums of I is previous one plus 1. It doesn't really matter, because here we say 8 changes immediately to 11, or previously the commented option was just 8 increased by 3. In both ways we do the same thing. If you're unsure about plus, like off by 1 errors and some where to use I minus 1, just think about a simple example like 10 and 8. Why int before num size? This it's some stupid C++ feature. Size is unsigned int. This is signed int, and that's bad. What rank did I get today? What rank did I get today? You mean in a lead code contest? I didn't participate. I wasn't home. Not that I usually participate. Hi Spyros Def 25. Please do Stone Game v next. Nice DP problem. I will consider. Okay, this one done. I don't think it's worth spending more time here. What did you suggest? Stone Game? What if race is negative? So, okay, one more thing about that one is that I had an if. See this? Only if this means right number is smaller or greater. So it's situations like this one or this one. In all those cases, raise must be positive, because raise just says by how much I need to raise the right number. So if this is true, then you can see here that this means that this term is bigger or equal than this one. So nums of I minus 1 minus nums of I is non-negative. Plus 1, that's positive. All right. Why do you have to mutate the array? I don't need to do that. But, you know, after changing 10.8 to 10.11, I need to remember that there is now 11 here for the next number to follow. If we can decrease, then that's a much harder problem. Just completely different one. It can be solved with DP, but I don't know if it can be done better than in quadratic time. I think so. But then I think we need to deal with some intervals that will be every next number is bigger by 1, and maybe we do transitions like that, but I'm not sure. Last one of today's contest. You're the second person suggesting that, I think. Then let's consider. They keep moving this to the side, that's bad. Okay. This one, make string sorted. Biweekly problem 4. Sometimes I cannot do biweekly problems too. Oh, sorry. I thought you were just talking about different platform, the binary search.io. So this one is hard. I am always on Windows while solving lead code problems. Unbounded knapsack. Is that a lead code problem though? This is harder to read, I think. Largest index I, such that number is smaller than the previous. So rightmost decreasing. I is rightmost decreasing position. Then largest j, so rightmost j. I'm changing largest index to rightmost because rightmost seems easier to think about, because you can visualize that. Largest index, it just means most to the right. So let's use rightmost for indices and leftmost, and biggest and smallest, or greatest and smallest, for values. Something smaller than the one before SI. Swap the two characters at those indices. Wait, those are characters? Yeah, characters. $3,000 characters. Okay, let's talk about an example maybe. If this is the rightmost such position, it means the previous one, si-1, was bigger. So let's say R. Then the next one is something quite small, E. And this is the rightmost such position. Then from this moment forward, we only want increasing sequence, like this. Now, largest index J, such that everything, okay, this is I, and we want everything up to J to be smaller than R. PR, I think this is then J. Everything from I to J is smaller than this thing, just before I. Greatest competitive programmer out there? If you're asking about the one with like most achievements, that's definitely Tourist. I think you already knew that. Yeah, I'm still not working for any corporation, that's right. Easier to use numbers? Maybe we will switch to numbers later. So I have the two characters at indices I-1 and J. So we swap R and P and reverse the suffix starting at index I. Let's write I and J here above. Swap those two. Wait, I-1 or J? I-1 and J, so P, R, reverse the suffix. Now what? This is a decreasing suffix, so very poorly sorted. We will spend some number of operations to sort this thing, I guess. And only once this suffix is sorted, R will move to be in the next character. While this is not sorted increasingly, the I found here in this part will be somewhere there. Like here, I and I-1 is here just because this whole thing is sorted. Only then, if there is sorted suffix, only then we modify the previous character. So I think what I need is the number of operations in order to sort this suffix, and this does not depend on the rest. And this suffix is sorted decreasingly. So what I need for sure is number of operations to sort a string of some length that is just right now decreasing. How many operations do I need in order to sort a string like this one of length 7? We find largest index I such that next character is smaller. That's here. I is there. Then I'm almost, I'm not sure. No, that's I am smaller. I'm smaller than the previous one. Okay, I is here. J, I guess, also will be there, and we will swap those two. I didn't put a link, right? Yeah. The link will work now. Will it? Oh yeah, never mind. Okay, I shouldn't think about just one operation. The number of ways, let's call it dp of 7, the number of operations needed to sort decreasing string of length 7 is whatever is the number of ways to sort this suffix of length 6. Then after that we are left with this 7, 1, 2, 3, 4, 5, 6, and this is like that thing. And then we swap. What do we swap? 7 with 6? Yeah, I think so. So plus one operation for this thing. Oh, we swap 7 with 6 and we reverse the suffix. So it will be now 6 and 7, 5 and all the stuff. So we spent one operation from this to get that. Then we need to sort this suffix of length 6. After that we have the suffix sorted. 5 will swap with 6. And everything else will be reversed. Okay, so this will repeat some more time for sure. Eventually, I hope I'm right here. Eventually, we will get 2, 1, 3, 4, 5, 6, 7. And just 1 will get here. Everything else will be sorted in reverse. Now we spend the last dp of 6 operations to sort the suffix. So always, when we look at 7, we deal once with moving from this to that. We deal with 6. Finally, we deal with this. I think it's 7 times dp of 6. Plus how many times we do the single operation. Once from 2 to 1, once from 7 to 6, I think it's 6. So in my opinion, this is the formula. dp of n is number of operations needed to sort, what am I doing? To sort decreasingly, to sort increasingly an already increasing string. C++ is easier than JavaScript. So look at me, baby, look, what a good nickname. Yeah, you can start with JavaScript. You will not go pro in competitive programming with JavaScript, but if you just want to experience the puzzles, sure. Well, dp of 1, by the way, is 0. dp of 2, according to this formula, it's 1. And that's right. You need one operation to sort 2, 1 into 1, 2. And the dp of 3 should be here 3 times the previous one plus 2, that's 5. Is it true? I don't even want to check, but I believe it. Now we get a custom string, not necessarily sorted decreasingly. We need to do something with that. I'm quite sure we will always focus on the suffix that is sorted, or maybe sorted decreasingly. Here de is sorted increasingly, but o isn't. And we have exactly this situation. Then we will spend some operations with the suffix in order to here transform. Okay, instead of R, did I mess up this? Why is it here P? Did I twice swap PR? Because this string and this one is the same. I think I messed this up. It should be like that. Of course. So if we have a sorted suffix of length k, then we need some number of operations to move from R here down to P, then down to the next character, the next one, the next one. Also, we have ties. Chat, you are right that this problem is quite difficult. For elite code problem is difficult. Also, people did not like it. And we don't have a lot of discussion happening. Implemented what they asked, but still time limit exceeded. Not the solution in uppercase. Thread to reach the... Maybe there is just something wrong with the tester. Or maybe 3000 square will give you time limit exceeded. My rank on Code Wars? I don't use Code Wars. Night probability next. If somebody else confirms that it's an interesting problem. Striver, you can suggest something, but preferably do that after I'm done with a problem. Like also, when you're posting a link, say a few words about the link. Like if I just see a link, then yeah, I will see tens of them. If I see why this is, you think, an interesting problem, I'm more likely to choose it. Splay tree? No. Right. In all the thinking here, I didn't consider what happens for ties, and I think it's unpleasant that there are ties. Should we think what happens for ties? I guess we should. All right, let's say that the suffix is sorted like this. And now what happens? I is this position, I think. Character is smaller than the previous one. Okay. Now find the largest such that everything up to J is smaller than this one. J will be here. That, and then reverse. In one operation, this messed up my plan to do dp of n, because it doesn't matter that there are n elements, it also matters how they are distributed. Like if there are ties, then it's not just n elements. Maybe those are n equal elements and I need 0 operations to sort it. Currents Doshi, are you spoiling the full solution? I don't think I wanted that. Better platform for interviews. Stack Overflow. I will ask you this. Which platform do you think is about interviews? Codeforces or LeetCode? Codeforces is just about competitive programming. It doesn't help directly with coding interview prep. Okay, but we can say what's the number of ways to sort this suffix that we deal with already. Can we? if I know how many operations I needed for this, and then we deal here with something, I think that the formula will just change to here that count diff is the number of different characters we already encountered, because that's how many times this character before the sorted string will change to the next character. So we should just go through from the right, see the suffix of the string, and use this formula. And when we encounter some character, let's say that we already sorted the suffix, so there is the full string. There was a suffix here and we sorted it. It is now 22, 555, 6. 3 different characters. And now we see here 3. Or say, okay, maybe let's make it less trivial. 7. 7 sees here 3 smaller characters, so 3 times it will drop down by 1. So 3 times we will do this repetition. If this is the of length, say k, then I need to increase the answer by dp of this case for this suffix length. How many operations I need to sort this? I think this gets multiplied by how many times 7 will drop down, and that's 3. 7 will drop down to 6, then 5, then 2. Plus I think 3 or 2 extra operations. Let's see, if it was 0 then 0, if it was 1 like this, then I would need 1 operation. For this, how many operations do I need? If there are 2 smaller, I'm just thinking if this should be -1, but I think we are roughly there. Why do you think that why do you think that Kylie is spoiling? I think he said something very reasonable, but again, that's a hint. Somebody already before said that. I want to solve this myself, and I think I will be able to do it. I already realized, thanks to the chat, that this problem is equivalent to something easier that I didn't think of at the first place, but this way I will do equivalent thing. Also, I am White Knife. Thank you for the rate. How much time an average person should spend on Medium? Depends on the problem. You can open the leaderboard, you know, for any contest, because there are contests, right? You can go to any contest here, open standings, see what rank you want to get. Let's say you want to get top 100. Then people around top 100 see how much time they spent on each problem. This person spent 4.5 minutes on B and 4.5 minutes on C. But also consider what happened for neighboring people. Take the average. This is how much you should spend if you want to be top 100. It's that easy to estimate. Oh, he copied pasted mine. I see. Oh, I see. Okay. Then I agree. Kylie, don't spam. I think I'm good here. Just this. I would say that this is again count diff -1. So 3 minus 1. But for 0 it would make no sense. So, okay, let's leave it like this. This is the number of smaller characters on the right. And this is the number of operations needed to just sort the full thing. So let's just go with this. number of different characters in this suffix of length k, and number of operations we need to sort this suffix of length k from decreasing form, so the worst one, to increasing one, so the final one. Let's see. Iterate from the end. And when you are here, count on the right smaller. If I am bigger than this guy on the right, increase smaller. No, I want to count distinct smaller. Like, did I remove something here? No. Like here, 7 will drop down to 6, then 5, then 2. Just distinct smaller. I can even keep this R. Let's just use a set, that's easier. Encountered or something. Smaller is just encountered, not size. This is much faster. I don't need n square for that, even though n square should be fine for this type of constraints. So I go from right to left, and as I go, I keep the characters that were already here. And oh, I need to, not all that were counted, just smaller. Then let's use an array. Boolean array of size 26. Just say visited. That's a simpler word than encountered. When you're looking at G, you want to know how many out of A, B, C, D, F, E, F were there already. Okay, this will count smaller, and we use the formula here. The previous kind of DP plus 1 and what's the DP? If for previous length we knew something, then what's for the new one? I think we use this formula for that. But here we have -1, that's suspicious. Times previous DP. Count diff is just how many in total we have. I don't know, maybe this is good. Maybe I got some off by 1 error. It's a bit inconvenient, I would say, to think about this problem. It's easy to make an off by 1 mistake. I always then just think about a good example. Maybe not always, but no. Output 0, that's bad. I'm rusty. Oh, yeah, but I'm not in a hurry, come on. I can use bit set? I can, you're right. But it's a stream where not everybody knows C++, so you know it's fine to use basic for loops. Web dev in 1 month? I would get some job, but not a good one. Right. CBA. Mark as visited. Go from the end. Iterate over smaller. Maybe smaller is always 0, but that's not the case here. Maybe DP is always 0. What if we look at BA? count diff. Oh, I see. Count diff should be after already I include this character. Yeah. When I look at BA and I want to know how many operations needed to sort this suffix, I need to know that there are two different characters here. Wrong answer. What now? Maybe it's good to test the string. With some printing. I could also do it on paper. Hi from Chile. I know that it's country in South America. I don't know all the countries, but come on, Chile is quite big. Where am I working? See the job command. What hourly wage? I think $100 per hour. But I'm not sure. I'm better than a lot of people at what I do. So maybe I think that I should be worth more than $100 per hour. But the market dictates that. That being said, it's a bit philosophical concept, you know, what somebody is worth. Like, are we saying that any kind of I don't know, a doctor saving your life, is he worth thousands of dollars per hour because he's saving your life? I think nothing about Ruby because I don't know Ruby. Let's print smaller, count diff, and dp. The first value is smaller, so only when I look at B something happens. Then I think that I will have the same mistake for just BAA. I got a mistake for BAA. That's good. We simplified the test where I got it wrong. So what my code thinks that this suffix AA can be done with one operation. But then we have B. So what happens with BA? I think it's described here. So we swap like that, but then we swap AB and then we reverse the suffix AB. I see. So it's not that we're left with that remaining suffix of length k minus 1, but I'm introduced there. Oh, yeah, that's not nice. Answer should be modulo billion 7. Yeah, I just want to pass samples first. You know, if I pass those, and I see that I only have a mistake for big test, then it means that, okay, I got it right, and then I will introduce modulo operations here. I treat this as, let's say, a draft. Coursera have 2 courses on competitive programming. There are a lot of courses in the internet. When I decided to do C++ profession, I don't know. It's not a moment. It's more like a switch throughout the years. Okay, it is, I think, wrong to just say that when I have my string, and now I look at this next character, look, going from the right, of course, then it's only important I should, for this suffix, know how many operations I need to sort it. Because when r is swapped with something, let's say with something smaller, let's say p, and then somewhere here it goes r, I think it goes there, but this string is now a little bit different than a moment ago. So I don't know how many operations I need to sort this. This is a bad way to think about it. And I think we need to do what chat said 10 minutes ago. Where I can practice DP, you can, for example, watch my videos on dynamic programming. My first programming language was Pascal. I don't think a lot of you knew about that. It's Pascal, not C++. But it was Pascal and then C++. All right, let's think about it in a different way then. When we look at this sorted suffix and then we just replace r with the next smaller character, like here we replace r with p because that's just slightly smaller than r, and now the rest of the string is messed up. From this we get this in one operation. There is some process in computer science, or just in strings, actually not in strings, that's more with sequences, where you get from this that. That's what we do when we want to find lexicographically next permutation or a string, where if you have all possible permutations of n numbers, and you have something, and then let's say 8 and 2, 6, 9, then lexicographically next, or sorry, lexicographically previous one, so just before this one, was something with 6 here, and then everything else is decreasing. It's a transition from this to that. So in reverse, we go and use some function to get the lexicographically previous permutation. And here, what we use is a function to get lexicographically previous string after permuting characters. Which means that what they ask is how many times we need to go from this to some previous string, or in other words, how many there are lexicographically smaller permutations of this string. Answer is 2 here, just because there are 2 ways to permute characters in order to make something lexicographically smaller than A, B, A, A. That's 3A and B, and then 4 A's and then B. Here apparently there are 5 permutations smaller than CBA. That makes sense because there are 6 permutations in total. And at the beginning I failed to get this observation. I failed to realize that this process is similar to something well known. How much time to become red without math background? I don't know, maybe infinite. I don't know. Maybe not infinite, because I learned math in 10 years, so at most you will add 10 years. I have no idea, really. Printed the competitive programming book? Cool. As long as it was that free PDF, and that was legal. And now the question becomes, how many there are lexicographically smaller strings? And that's an easier problem to solve. At least an easier one to think about. It cannot be easier to solve because it's the same problem. But if you have some string, like this one, then, and you say that your new string that will be lexicographically smaller is smaller on this position first, because maybe this one has I here, or it has E, or it has G, then you need to know how many ways there are to here fill this suffix with all those characters minus G. So the number of, I just want the number of permutations of this suffix if I ignore G. And there is some binomial, so there is some formula with binomial coefficients for this. So we completely change our solution. For every position, I want to know what happens on the right. In order to achieve that, I will again go from the right. Instead of visit, I think I will have frequency. For every I. Now I'm looking at some position, like this is I say R. It doesn't matter that this is sorted. This is just R and then some bunch of stuff. Then I can iterate over what character to put here. For every new character, let's call it new NW, starting from A, ending with this one being here. Let's say that I'm putting this character. Of course, 0 means A, 1 means B, and so on. 25 would be Z. Assuming that frequency of this character is greater than 0, assuming that this character exists already in the suffix. Okay, I'm going from the right, so frequency keeps frequency of characters in the suffix to the right. I would say including this one already, because I want to do now when I'm putting here instead of R on the first position to say I, E, G, then R goes to the right, of course, so it's a swap like this one. Let's say G goes here, R goes there, and now I want to know how many permutations there are of this suffix. And again, there's binomial formula for that. The formula using binomial coefficients. Okay, then for a moment let's subtract this. Let's decrease this by 1. Later we will move this back. But here I want to say, I use this frequency array to say how many ways there are, how many permutations there are. And what's that? There is this length, n minus I minus 1. That's length of the suffix. Iterate over characters, and out of that many slots, you choose C, where C is choose function. Out of that many slots, you use frequency of C. For example, if suffix is of length 10 and you have 3 occurrences of some character C, then there are 10 choose free ways to choose where character C goes. Okay, and then the remaining length, the remaining number of slots left is decreased by that. Here answer should get down to 0. This will be an array that I pre-compute. And answer, what is answer? Last thing, pre-computing the binomial coefficient array. After creating n, because this will be of size +1 by 26, I think. No, the frequency of character can also be up to n. Oh, then this is n squared pre-processing. Yeah, that's unfortunate. That's quite slow. For now, I'm not using modulo operations. That's on purpose. Just to make things simple for now and see if it works for the first 2 sample tests. Come on, come on, come on. Oh, What now? Artek, I'm speaking English during the chat. But you can write to me in DMs. In Discord, for example. What can I do? Run example test cases. There is a button here for that. Cool. Thank you. Thank you, Jarek or Jarek. Yeah, I don't care about those. Oh, still, let's focus on something small. We passed the first two tests. Can I check multiple? I don't want to do the last one because I know it doesn't work there without modulo. This is the first test where something's wrong. Then what is it? This problem would really appear? To count smaller permutations of a string, it for sure can appear. This one, the statement is too artificial and complicated. It's unlikely that this one will appear. But the problem of count permutations smaller than this permutation, lexicographically, can appear. But it's much easier with permutation where there are no ties. You should not know solution to this problem. You should know the solution to the problem given a permutation numbers 1 through n, count permutations of the same size, lexicographically smaller than this one. Than the given one. Okay. This you need to know. But this is easier and you can use factorials, where you know that the number of ways to permute the suffix is just suffix length factorial. Okay, I'm reading my solution. Binomial coefficients are good. They seem good. Count the frequency so far, including this one. Iterate over the smaller character to put here. Only if the frequency is not 0, so you can actually put something smaller here. I mean, there was a character here. Yeah, I think that no, this should work. Classical permutation problems. Well, this is one of them, but yeah, there are. It's hard for me to find some, just like that. I would need to search for several minutes at least. Last thing, modulo. $1,000,000,007. I wonder if we get accepted with just slow modulo operations. This is not taken modulo. What about that? Let's run on all sample tests. Now I know how to do it. How long programming? Now I'm confused, like, starting from some age, for several years, nobody asks you about your age, and then you wonder, oh, actually, yeah, what is it? I need to subtract. Then, I'm I just forgot. 10 years? 12? 12 years? Okay, got time limit exceeded. What's the complexity? It's n squared here, and then n times 26 times 26. So both parts could be a bottleneck. First of all, this could be done once, and in lead code they run your program multiple times for various test cases. So it's better to make this here. Should I use an array? Let's use an array. 3000. If this wasn't computed yet, then do this, but for the max n, so that you could use it for all the test cases up to max n. And now it will always do the whole 3000 by 3000 thing. Max n. I'm doing something wrong. What do you want? So now, this couldn't be local? Oh, I see, because it wants this array to be of size that is constant, but actually something local here isn't treated like that. Well, yeah. But actually I would prefer to make this global too. I don't know, but it would be, I think, better style to put it inside the class. Well, whatever. Yeah, so we speed up one part, not to do it again and again. Okay, pass the test. Next thing, I could speed up. If I still got time limit exceeded, I would do it. In C++, modular operation is quite slow. If you just add two numbers, then just check if you if you exceeded modulo. If yes, then subtract modulo once. You can do it always for addition, for the addition of two numbers that are already taken modulo. Let's see if it speeds up anything. But I don't know now if this is still a bottleneck. Maybe this part is. This one is n times 26 squared. But 26 square will be hit only if this is full of big characters. If in the string there are a lot of characters like z and y. 100% faster? Do you mean 2 times faster? Yeah, I think it's possible. Now, can we speed this up? Not really. We need a model operation here. Maybe this can be done actually without this for loop, just with some kind of DP. If I know how many ways there were to do something for the suffix and now I get new character, maybe I can update it in some way. Another thing to avoid this is to just precompute factorials and do modular inverse in order to just avoid the two-dimensional array completely, and then you get rid of n squared in complexity. You will just have linear solution times alphabet, or maybe alphabet squared. Well, still, this is good enough for sure for this problem. Please don't repeat your comments. Faster than 100%, you mean? Oh, only if they round up the time. Maybe not if they round it. If they mean faster than this percentage of remaining submissions, not including yours, then yeah, you can be faster. %100 faster usually means faster by 100%, so it's actually 2 times faster. But here, of course, it's just what percentile you are. Of course, there are fluctuations, especially if your code is very fast and it will be around 1 millisecond. Then running it again can make a big difference. Instead of 1 millisecond, you will get 3, and it will turn out a lot of people got 2 milliseconds, and this percentage will change a lot. Hi, Milu. I hope you're enjoying the stream. I am taking part in Division 1 contests, and stop saying give a contest. You don't give a contest. All right. So it's already 1 hour. I think we need to find another interesting problem. Why greedy solution is optimal? We already did something greedy today at the beginning. Remove k digits. No, I don't know. What do you want now? Easy, medium, hard? Oh, maybe I want to test a poll. Or I'm not prepared for that. No, okay, another time. Easy, medium, or hard? You vote just by typing a name, which is, you know, a poor man's voting system, but it is what it is. I'm lazy. Medium. I'm just looking at titles of medium problems. I'm choosing something medium. Hardest medium. Okay, that's an interesting idea. Let's choose medium and sort by acceptance. And choose something with small acceptance, but not very old, like 8 and 29. I think that these have small acceptance mainly because it's just one of first problems and people who don't know lead code are doing those. So I think that this will not be, oh, okay, that's just an ugly problem. Something recent with small acceptance, like this. Big number means a recent problem, and small acceptance strings. So this is the hardest medium problem. Actually could be a title for a YouTube video. No, too long statement, I think. I will just see. Avoid flood in city. It's not badly received. I will read this anyway. This is harder to understand. Segment tree. Segment tree is not a technique you should use in interviews, so I will not solve during lead code streams. I will not solve segment tree problems. Do you teach Blue Jay? Is that some kind of a sex thing? What is Blue Jay? Okay, did you guys understand that statement? BlueJ is an IDE. Okay, well then I don't use it. I didn't like the statement, it's just too hard to understand. I don't want a problem that people fail because they didn't understand this. I think it will be DP. Count good meals. I want to count good meals. Exactly 2 different food items with a sum of deliciousness equal to a power of 2. This must be easy. Okay, we're doing this one. It has very small acceptance rate, so let's see if I get it right. Sum of 2 numbers needs to be equal to a power of 2. I will just iterate over powers of 2 and no, just if I know one number, I know the other. What can be hard about it? For example, if I see that deliciousness of, let's say, of some kind of I is 6, then I know, well, maybe the sum is 8, and then I'm missing a number 2. 2 together with 6 will form 8. Maybe the sum is 16, and then what I'm missing is 10. So if I have 6 and I want the sum of 2 numbers 16, the other one must be 10, and so on. By the way, this is, I think, called two-sum problem. There is also three-sum version. This is, I believe, something similar to what Google described in a YouTube video. If you search in YouTube for Google interview problem, then Google shows you one of them, a very easy one. I think it's two-sum. Let's try. We have here this up to 2 to 20. I will use a map for frequency for everything in deliciousness. Let's iterate over powers of 2 from 1 up to 2 to 21, I guess. Answer plus equal frequency of power minus x. The sum I want to get minus this value. And then increase the frequency of x itself, return the answer. Can this fail? To help keep the stats for this problem, I'm not going to test on samples. Let's just submit directly. I think testing on samples will not count towards the low acceptance rate. So this is more interesting. Modulo, right. I can type. You don't see it, but I typed it like that. Again, submit. I will not bother testing on samples. I already got wrong answer on this test, and I was stupid enough not to care that this is not an overflow. This is not about modulo. Right? Well, here 10 seems to be the number of all the pairs. Power plus plus isn't what I should use. Times 2. Okay, first try. First try if you ignore those. Oh, you see, first try. Easy. Okay. I helps the acceptance rate to converge towards 33%. I'm still surprised. Of course, those were very stupid mistakes. I mean, in any problem you can make those. It wasn't specific to this problem. There are a lot of problems about module operations. Here, I don't know what people did to get such low acceptance rate. What's the optimization though? What optimization? This is? a solution in complexity n times logarithm of values times, well, using a map, so it's logarithm of coming from a map. This shifts binarily 1. This is just, 2 raised to power 21. In Python, it would be this normal thing, 2 at power 21. So I iterate through powers of 2 from 1 to 2 million. Okay, maybe somebody in this class can describe. O of n? That's not O of n. That's O of n times logarithm. If we ignore logarithm in complexity, then you can say that we sort in O of n. And I know it comes from log of value, still log of n is also a value. Right, one more medium hard problem. I guess I didn't give you a link for this one, did I? So the link was this, by the way. Validate IP address. This might be a good golf problem to make your code very short. Ugly number 3. Maximum value at a given index in a bounded array. Yeah, bunch of conditions. Boring. Did it keep my sorting? Yes, it did. Positive integer that is divisible by a, b, or c. Return nth ugly number. Wow. What a boring problem. I'm not saying it's easy. I'm saying it's boring. It's tedious. You need to know how to do it, basically. I wouldn't use it for sure in an interview. As an interviewer, I wouldn't use it. I'm not an interviewer, but I know what they should use and what they shouldn't. This was an example of bad problem. Or actually, maybe you can come up with what's needed there. Is there some cool problem here? Lead code hard problem on DP. No, thank you. And also don't paste your comment twice. Solve it. What? The one from a moment ago? What are you talking about? Oh, this one. This one I skipped after just glancing at the statement. Ugly number is not about priority queue. Isn't it inclusion exclusion? How do you want to use priority queue? There are a billion numbers that you want to go through. If n was smaller, then we could do something like priority queue. It wouldn't be priority queue because we would just deal with 3 elements, so that's easier than that. Yeah, it's not just a simulation. My solution is spoiler alert. Okay, I will just say it. So spoiler alert for the next 10 seconds. Binary search plus inclusion exclusion. That's the solution. Sell diminishing valued colored balls. Let's do some economics. Or let's just start at the animation. Okay, looking at this, what about we guess the statement? Let's guess the statement by looking here. Orders is 4, so I think we need 4 balls. whenever you take a ball, you get as many points as there are balls of this color so far, right? Initially there are 2 yellow balls, so when you take yellow, they move 2 here. When they take blue, 5 is moved there. If you want to just... Okay, and orders is the number of remaining orders needed. Then if we maximize, I will just take as big as possible. So... if we can do brute force, why is inventory a vector? Maybe there are a lot of maybe there are multiple colors of balls. Always we need to take the maximum element here. If let's say the inventory was 2, 5, 6, 3, it would mean there are 2 balls of one color, 5 balls of another color, 6 balls of another color, and so on. And we maximize, I think. So we first take something from here, then from 5 and 5. So we should sort this decreasingly, and then keep taking the first one. And I guess that orders can be up to 1 billion. Orders is this value here. Otherwise the problem would be too easy. But still, for 1 billion we can do it, because we can keep looking at some prefix. Pause the question link. I don't get the statement, you don't get the statement either. Do you think this is all reasonable to assume? Because I think that's reasonable. But I want to rename this. This is sorted decreasingly. I should read it? No, I shouldn't. You should read it. But I wanted to say I will not even show you the name of the problem. Well, it's here. Okay, here you go. This is the link. It's more interesting, to be honest, to guess the statement just by looking at the title. I can once just do it maybe during the whole stream. Can I win? Of course, it's impossible to guess. But like surrounded regions, I would say that it will be a 2D grid with islands. Is it? Okay, well, it was a 2D grid with islands. I still didn't know what then, but I can keep guessing. Here the title wasn't really enough. Okay. I'm assuming that orders can be up to 1 billion, and I cannot do things in complexity of orders. But for every I, look at this prefix up to ith position. Then there is some kind of drop. To do fix this if I is already n-1. Or just let's do it now. If it's n-1, then this, otherwise 0. Okay, what's diff? When I look here, diff is 2, 5 minus 3, because those numbers I can decrease by at most 2. Serpra something, you get a block. It's one thing to keep repeating your comment, it's the other if it's, you know, paragraph long. Okay, we have prefix of this length, of some length. So the length is the number of elements here. Diff is by how much I can now decrease them. And the initial value is a of I. Now what happens? I can as long as orders allows me for that, I will... An example is this. Let's say we have prefix of length 4, then the next element is 5, so then prefix is 4, diff is 2, that's 7 minus 5, value is 7. Now, I assume that I can take from 7, 7 will be decreased to 6, and I will get 7 to the answer. In total, I can get 4 7s. So, slow version is this. Starting from value, or just repeat. No, I prefer to start from value. Starting from value up to value minus diff, value minus, here, up to that many times I get value. And orders minus equal. Okay. I believe that this should already work for samples, but we will speed this up. Do we want to test it on samples now? Or would that be, you know, too bold of a move and we just submit directly? No, I'm not doing code forces problems today. Let's test it. No, let's not. Then just always test. Okay, always test. Run code. Submit? I will not submit because this will get time limit exceeded. Answer doesn't exist. Maybe answer needs to be taken modulo billion 7. What about that? We need to return this. Yeah, just in case. Let's guess that they want us to take the value modulo billion 7. Yeah. And I think that submitting is still too slow. Now, submitting is limited by it's O of billion if values in the array can be up to 1 billion. So I think that now submitting will give me TLE. Do I pass all example tests? Time limit exceeded, you see. Now we need to speed this up, and for this I can know how many times this gets repeated, and it's very regular. If I know that I want to add to the answer 4 7s, then 4 6s, and so on, I can quickly do that. So I can do that many repetitions in total. Like if orders is 10, and I know that I'm looking at 4 numbers, then 2 times I will do the full repetition. I need to minimize this with diff, of course, because only that many repetitions I'm allowed. Now, what's the formula? Like if I'm starting with 7s, that's value, I will end with value minus times plus 1, because there are times numbers here. So here it's value minus times plus 1 over 2 times times. That's just arithmetic series sum. And I think additionally multiplied by pref. I think that this module is unnecessary, but I'm not sure. Just in case, let's do it. Okay, this is like the fast sum of 4 7s, then 4 6s, 4 5s maybe, and value minus equal times, and then the rest can be brute force because it's just at most 1 step. It's important that I do those full force very quickly. After I solve this problem, I will for sure look at the statement. Mod. And sorry for a big font. I think now the font is just too big, but I don't want to see the statement. Oh, well, I could do this. Oh, what now? Maybe I just messed up the formula here, right? That's how many full repetitions I make. Now I know. Orders, I don't decrease orders. This is just a way to speed up some iterations of that. Submit and this must pass. Come on, what can be wrong in a statement that you don't read? How did you know about modulo billion 7 without reading the statement? Modulo billion 7 is the most common modulo. Oh. It's the most common modulo, and here I don't see how an answer should fit in int. If I created the problem that I guess the statement for, the value orders and values in the array would be up to billion 7, up to billion, and then the answer can be quite big, like 10 to 18, maybe 10 to 27. It wouldn't fit in int. So for sure they told us to use modulo billion 7. Yeah, it's a prime. It's the most common prime that you see as modulo in those problems. And maybe this problem has low acceptance rate for exactly this reason. Everybody is trying that without reading the statement. What did I get? Time limit exceeded. Oh, when orders is 0, then we should stop this, otherwise this is still equally slow. Submitting again, pending judging, and easy, accepted. Oh, the statement was long. I wouldn't do this problem if I saw that it's that long. I wouldn't bother reading it. But it's nice that they provided a drawing, and I would say that drawing describes everything. I can get paid for guessing problem statements. Will you pay me for that? It's a cool sponsorship deal with some company, like say LeetCode. LeetCode, if you want to sponsor me, I'm fine. I can do a stream just advertising your, I don't know what is paid on LeetCode. Well, the subscription. I will say that subscription is cool. If you pay me for guessing statements just by looking at the title or a drawing. All right, I hope you enjoyed this stream. On YouTube, by the way, if you didn't know, on YouTube there are all the recordings of past streams, and also even right now you could watch on YouTube at the same time. Head there for past streams. And what was I saying? I don't know what. That on YouTube I will put a list of links for problems we did today, so that you could easily jump through that or search for something. I need to start doing that for all the streams. I can use such animations in your lecture videos. I just simulate them by hand when I describe something. I will show you my version of what that would be. I will just draw. Let's say there are some yellow stuff, some blue stuff, and I would just how to do this. Actually not that. I will simulate it this way. Oh, this moves here to the right, and then it's easier with drawing tablet, and I just use a mouse right now, so that's harder to achieve. Oh, text. I want text. Well, okay. Oh, and this give you 3 points. Here you go. That was a very amazing animation. This one is just similarly cool. We also want solution. In CodeChef, you need to guess statements because they are not visible for 30 minutes. But do you at least see the titles? You know, in competitive programming, it's harder to guess stuff. In LeetCode, everything is standard for us, competitive programmers, because we saw this as a little part of a problem, like tens of times. Like here, I saw something like this or another problem that uses this technique before. It's not that this was brand new for me. Or when the title is reversing binary tree, you know, title is actually the whole statement. Do more questions. I already do a lot of questions during the stream, but feel free to go to Discord. That's not how you spell Discord. Feel free to go to Discord, join the server. You can hang out. You can ask questions, leave suggestions for my videos and streams. All right, LeetCode, pay me for guessing your statements. Everybody, thank you for watching, and see you, I think, on Tuesday. And watch out for a new video on the main channel, which is youtube.com/ericto, about sparse tables. It's already recorded. Maybe we'll go live today. Not live, I mean go public. Bye. And quickly looking for somebody to rate. Okay, YouTube, I'm finishing the stream.